I'd like to introduce Lisa Carey Moore. She's Senior Sustainability Manager for Integrated Eco Strategy, which is a healthy material consulting and software firm. So Ms. Carey Moore works with owners, manufacturers, specifiers, and contractors to ensure material compliance for projects pursuing Living Building Challenge certification, which you're all familiar with. Her recent work includes Hampshire College's R.W. Curran Center and the Hitchcock Center for the Environment, the Nuthatch Hollow Environmental Center at Binghamton University, a large laboratory project in Allston, Mass. That's nice to hear, and the Williams College Environmental Center. So as an environmental advocate, Ms. Carey Moore has successfully lobbied state and federal officials, securing vital funding for municipalities requiring sewer and stormwater system upgrades to meet the Clean Water Act, as well as participating in development of a habitat restoration plan for Long Island Sound. So the importance of learning what materials to specify and use on a project is the reason Ms. Carey Moore was invited to speak to us, as these materials can have significant enduring health effects and impacts on a building's occupants, the community where the products were made, on the workers who manufacture and install them, and on the much broader context of our global community. So please welcome. So this is time for some virtual applause, Ms. Carey Moore.
Thanks, Carl. Hi, everyone. I'm really excited to be with you virtually. I'm sorry that I can't be on the UMass campus in your beautiful new building and with you all. It really helps when I'm surrounded by people. I love facial expressions and all of the sounds that come out of an audience. And but I just want you to know that at the end of the presentation, I'm sharing my contact information. Please feel free to get in touch with me if you have any follow-up questions or want to talk more about the future and your role in it. So I want to start by saying that since 2010, my practice and our firm, Integrated Eco Strategy, has very much been inspired by the Living Building Challenge and the programs that it oversees. As Carl said, most of you are familiar with Living Building Challenge and the various projects in Western Mass. The Bechtel Center at Smith College is another one. We did not work on that project, but you have ample opportunity to go and visit those buildings and hear from the people that are using them and running them about their novel systems. And it's a tremendous program, and it really has fundamentally changed the design and contracting and consulting teams who have worked on them, because it has a mission that is very different, to catalyze the transformation towards communities that are socially just, culturally rich, and ecologically restorative. So what does this mean? Socially just means that those buildings are accessible to all. If people have disabilities, they're still able to participate fully in the space. If people feel marginalized, they feel invited. LBC calls out the fact that living buildings should be open and accessible with some, control measures in place to homeless people as well. So socially just gets at that. It's about equity. Culturally rich means that those buildings are tapping into the history and surroundings where they come to fruition. And they're not trying to be something that is special, a special unicorn, if you will, but they're really trying to speak to what exists and the potential for the future of that area. Ecologically restorative has to do with a building that gives back more than it takes. Okay, so if you've been to Kern, Hitchcock, any of those buildings, you've seen on your tours the novel systems of energy and water that are supposed to produce more than the occupants use. Ecologically restorative also taps into this idea of biophilia and how a project's design should consider and employ elements of biophilic design so that we feel very connected to the natural world. It also obviously taps into the use of native and adapted plants for landscaping. If that all seems too complicated, then let's just think about this phrase of what does good look like, okay? So if we're working as a practitioner in the built environment, we want to think about our daily actions and what we're doing and how that's having an impact, not just on our project, but on society as a whole. So here, if you're looking at this screen, you know, what we're talking about is obviously not a building that's built to code, not even a green building. And we're going beyond even high performance buildings, because high performance buildings traditionally, and the certification programs that have promoted them, traditionally have still thought in terms of minimizing impacts. And really what we're trying to do is we're trying to get to a place that is truly sustainable so that we're positively impacting, we're giving back again more, both in social, cultural, and in environmental terms. So it's truly regenerative. So here are some snapshots of living buildings. You can go onto the International Living Futures Institute website and see so many of them and read on their case studies. But before we get into sort of talking about the nitty gritty, I want to start at the high level, and Carl talked about this, you know, the importance of thinking about materials, considering materials, has to do with more than just how you put your building together. Here's the problem. So we have up to the left, the sun, and then our moon, and the ratio of human-made chemicals in this country to those tested for safely was once roughly 80 some odd thousand to 300. Since the passage of the Toxic Substances Control Act in the 60s, we had 26,000 chemicals that were grandfathered at the time of passage, because of course it was probably pretty contentious to get that act passed. So, you know, they had to make a lot of concessions. But since then we have had tens of thousands of chemicals that are added. And the crazy thing is, if I were in the auditorium right with you right now, I would ask, show of hands, or, you know, call out, how many chemicals do you think have been banned? And the answer is 6, okay? We've only had 6 chemicals that have been banned. And typically it takes decades to get those chemicals out of the marketplace, just because it involves politics. When Congress finally passed an update to the Toxic Substances Control Act in 2016, giving the EPA a mandate to get going and to do an assessment of chemicals in the marketplace and to prioritize those chemicals that really needed to be studied so that they could understand the health and environmental impacts of those chemicals. So EPA was given the mandate to look at least 20 chemicals in the next 5 years. That's 20 out of tens of thousands of chemicals. What EPA did achieve is that they got that number down to about 42,000 chemicals that are actively in the marketplace. And the problem is that if you're looking at chemicals once they're in the marketplace, you're already potentially dealing with those that are doing harm. So for many of you, the concern around PFAS or PFOA, the Teflon family of chemicals, is is probably pretty salient right now. The movie Dark Waters came out. For the last 3 years, we've had some pretty awful news stories about the contamination of drinking water. And, you know, that's a persistent and bioaccumulative chemical. It's also sort of called a forever chemical because it won't go away. And so that's on the fast track. And the authorities are looking at regulating chemicals in the Teflon family more, but that's still going to take another 3 to 4 years. I want to contrast that with what happens in the European Union, where when chemicals are coming to market, a company is responsible for doing their own due diligence to make sure that chemical is not going to have an adverse effect. And so the European Union really puts the burden of proof on the manufacturers to do that work. And if you're going to bring a chemical to market in the EU, if it's a novel chemical that might only be used in a lab setting, then that would come to market with less perhaps research because, you know, very few people would be exposed, as opposed to a product that might end up in consumer products, or a chemical that might end up in consumer products. So again, EPA is playing catch up. There's very little burden put on manufacturers in this country, and that is one of the real reasons why I feel so passionate about doing my part to address chemicals when I work with manufacturers. Here are just some of the health impacts. You're not supposed to read this, but I'm going to give you a little homework assignment on top of everything that you've been given by your faculty members. And that is to go to the website of the Green Science Policy Institute and watch these 3 to 4 minute videos on different classes of chemicals that they have identified. And these classes have been adopted by many practitioners, including Harvard University, who we've been able to work with recently, as a lens through which to look at building products and to try to get to healthier options. Let's take just one category of building product and chemicals of concern, because it's so ubiquitous in the built environment, and that is PVC. So 75% of PVC is used in construction materials, okay? 75% of the PVC manufactured is for our built environment. That represents 14 billion pounds of PVC per year. PVC is based on chlorine. It's not a hydrocarbon plastic like polyethylene and polypropylene. It's based on chlorine. And as a material that is based on chlorine, what that means is in its manufacturing, it is really, really toxic. Okay, so we have dioxin and ethylene dichloride and such that are a byproduct. And so it's a serious chemical of concern, and yet again, it coats our electric wires, it serves as waste pipe, it's used in everything from carpeting to electronic products. So it's a real issue. Let's think about this from another angle, okay? If we're working in perhaps a market space where we're trying to compete with others, say we're a developer or a building owner, and you know, we want to distinguish our space from other spaces. Cognitive function might be a metric by which to promote the virtues of having healthier spaces. So the CogFX study was launched, I think, in 2014. The report came out in 2015, so maybe it was a little bit earlier. And it's between the Harvard Chen School and Upstate Medical University up in Syracuse, New York, where I used to live. And the focus was to look at the impacts of indoor environmental quality on productivity. And they took a building in central New York that is essentially, it's a laboratory. It was set up with all of these really sophisticated systems and controls to allow researchers to test exactly this type of thing. And so what they wanted to know is, in a typical green building, say, a building that has addressed their volatile organic compounds by thinking about interior products and the emissions from those products. What's the difference between that and an enhanced green building? And in the case of this study, what they're talking about is basically doubling the ventilation rate from the ASHRAE standard, so to 40 CFM. And these, right down here, you'll see these little diffusers, maybe not too well on my screen, but they have these diffusers throughout this space, which is set up as typical cubicle style. And what they did was they introduced all of these VOCs into the space, like formaldehyde and like different cleaning products and wet wipes and dry erase markers and such. And then they waited. And so this person is 2 floors below those cubicles. And as you can see, very, very, very cool high-tech space. And this researcher from Harvard is sitting here, and they're monitoring the inputs as well as the air volume. And what they found at the end of the day, because at the end of the day, they administered these cognitive functioning tests, okay? And what they found was that in a situation where you had just low VOCs, okay, a green building or a green, what they characterize as a green building with, you remove the VOCs, your cognitive functioning was 61% better than in a typical building. And then if you increase those ventilation rates and you really super flush that space to make sure you had the best air quality and then you were looking at 101% improvement in cognitive functioning. They also looked at what this would mean in terms of worker productivity, because again, if you're speaking to, say, somebody who's trying to lease office space, that might be important. And what they arrived at was that was the equivalent of increasing a worker's productivity by $6,000 per year, per worker. That's a big deal. It's also a big deal in the education realm where, you have people that are maybe in higher ed, but certainly in K through 12, where you're trying to, make sure that students in spaces are not only getting the right material, but they have the ability to process the material and apply that material in testing environments. But the problem with the ventilation rates is, a lot of mechanical engineers really like to talk about, we can flush a building like nobody's business. The problem is that if you have chemicals of concern in your environment, it's not just about air quality, it's about environmental quality. So flame retardants, for example, are inherent in all of these different things, okay? And the challenge is that flame retardants can be ingested via dust, because all things over time degrade and create dust. And so flame retardants, like so many other chemicals, adhere to that dust, and that dust can be ingested, and they can also be absorbed. So that's a challenge too with things like bisphenol, where it's absorbed through contact. So ventilation doesn't address that. We really need to think holistically about what we're putting in our building to make sure that we're not being exposed. And that's also important because it's not just about the building occupants, okay? There's this whole supply chain that that will allow for toxins to have a negative impact if we don't address it. So we have extraction, the workers working to extract things, and that's where, asbestos, the incredible thing is asbestos is still not banned in this country, and workers are still being subject to the danger of being exposed to asbestos and other things. Chromium-6, hexavalent chromium, is another chemical of concern that's really toxic to the workers who are plating metals with chrome plating. It doesn't have any impact once it's in our chrome faucet in our building, but to be concerned about the entire supply chain and the people that come into contact is really the goal here. So it's really about reducing the toxins through our advocacy and slowly getting to the elimination of toxins to benefit all. The last thing that I want to talk about that's really becoming such a driving force in the last 2 years is this issue that embodied carbon will be responsible for almost half of total new construction emissions between now and 2050. Okay, so when we're talking to manufacturers about product chemistry, we also have an opportunity to think about how that product is being extracted, manufactured, transported, and its entire life cycle. Because once we specify a product and procure it for our building, the embodied carbon is set. It's not like operational emissions that we can address through commissioning and adding solar panels to our rooftops. Once we select that material and put it in our building, then we've got it for the remaining life of the building. So the challenge is to, through our work of understanding product chemistry, we also have huge potential to start asking manufacturers about embodied carbon and asking how their material compares to somebody else's material. So if we have 3 equal carpet tiles that we could specify for our building, maybe what we can do is put an emphasis on specifying and procuring the one that actually has the lowest embodied carbon. And concrete and steel and iron are the 3 main drivers to embodied carbon, but that doesn't mean that we should just ignore the impact of all the other materials in the building. So the great news here, okay, I've given you a lot of sort of, oh, it's not good, but the great news is that the building community really has responded, okay? Through all of these programs, including the Living Building Challenges Red List that was initiated in 2006, we've had this explosion of health product information, okay? And what that means is we have far more opportunity now than we did just 8 years ago to make an impact. And I cite 8 years ago because 8 years ago was when we really got immersed in the work of reviewing materials for Kern and Hitchcock, and we had to look at so many different materials. And when we first started, there weren't a whole lot of labels out there to give us information about what was in them. So it was a one-off, working with each manufacturer to try to determine that and do better. Since then, we've had the emergence of many more labels. The Declare Marketplace is now almost 900 labeled products. The Health Product Declaration Marketplace is now, I think, around 4,000 products. And so there's this emergence of information, which is really fabulous, as well as places like Mindful Materials and UL Spot, where we can go and get this information. So I want to finish kind of this summary with, here's an instance where it was not regulation that made the difference. Between 2005 and 2014, formaldehyde emissions plummeted. And this was based on the fact that LEED materials and resources credits started challenging project teams to get formaldehyde out of especially insulation and paints and coatings. And so this is to say that just by asking for better product chemistry, we can have a real impact on the marketplace. And that's needed because, again, at least in this country, our federal system is not set up to initiate rapid change as is needed. So again, product demand, okay, our questions will help drive the production of products that are healthier and drive down, hopefully, the production of products that are less healthy. And the more participants in this act of asking for better products, the shorter the time frame for reaching our goals. So let's start with transparency. It's all about transparency. Catherine McCusker can tell you that when we started, we sounded like sales agents. We had to ask, what is in your product? This is why we want to know. No, we recognize these chemicals aren't regulated by the federal government or the state governments, but we still want to know this because we're trying to get this project certified for Living Building Challenge, and that means we need to use the red list and avoid chemicals of concern. And it took forever, and it was painful. And what we were really asking for, though, is just tell us what's in your product so that we can determine if it has a chemical of concern. And so many of them were not in that place at that time. So again, we used the red list then, we use the red list now. After this call, you can go online and find the red list and download it. It's in an Excel format. And you could use the red list when you make your next purchase by going to, say you're going to buy a chair or table, and you can go and ask the store, well, does this chair or table have a transparency label that would tell me something about its product chemistry? Because I'm trying to avoid these chemicals. And there you go. You've joined the advocacy movement. So as I said, there are a lot of labels out there. Some are better for health and transparency. Declare and health product declarations are two websites and resources you should look at to educate yourself about what's available in the market and the formatting of that information, and to sort of understand how to read those labels. An environmental product declaration is really all about carbon. They have different looks depending on who produces them for the manufacturer. But again, if you're coming into the workforce in the next couple of months or next year or two, you're really going to want to know about these different sources of information and what they mean to you and the decision makers who will be in your world. Cradle to Cradle, I should note, has this high level look at sort of health and carbon, but it doesn't have transparency. But if you have a Cradle to Cradle label that has at least a gold level of material certification, then it meets the red list. And last but not least, GreenGuard, as with so many other labels, they deal with emissions, but they don't really deal with content. So here's a Declare label. Again, these are the chemical abstract numbers, which is like a unique fingerprint that every chemical has. So if you were to get a safety data sheet from a company and it was all in Mandarin, I myself cannot read Mandarin, but I can look at this number, and because I have the Excel spreadsheet from ILFI on their red list, I can compare this number to the numbers on my spreadsheet and see if I have a hit or not. So a Declare label is the most easily used label to date in my experience. And it's a great tool because not only does it give you the ingredients if you care to know them, but it also tells you, if you look at the label, if something's completely free of the red list, or if it's just compliant to LBC. And what compliant means is that there's some market reality out there that prevents a product type from being free of the red list. And so LBC acknowledges that market realities exist. They have over 28 exceptions currently for product types, different product types to acknowledge this reality. So LBC compliance still means it's best in class, okay? Nobody's beat it yet, because as soon as somebody figures out how to solve a problem, then that exception will go away. And lastly, these labels can also just declare all of the ingredients, but also have red lists. So when you go to the website, take a look and make sure you know what that label is telling you about the product. Is it free of red list? Is it compliant with an exception? Or is it just being transparent? So when we understand products, we have to start with sort of knowing about what's in a product, right? And there's a lot of opportunity here for teaching yourself about obscure things that when you go to hang out with your friends, they're totally not going to want to hear about. But it means that you can speak more knowledgeably with, as a contractor with a design team, as a member of the design team with a contractor, because you really learn intimately about what goes into the fabrication of a product. So for a door, for instance, we have core, right? Some core material, maybe an insulation material to provide, fire protection or acoustical properties. Maybe it's hollow, then that makes it easier to review because we don't have to know about that material in a core. It definitely has adhesives and it has some hardware. It has a finish maybe, and it might have some seals, gasketing. So if we have a door manufacturer like Assa Abloy, where they've got dozens of labels on their product that tell us about product chemistry, we are lucky because we don't have to then go to the supply chain and ask about each one of these things separately. But right now, we're still doing that in our materials research because not everybody has a label that speaks to the component parts and the chemistry. And so, again, when we're doing this work, it's important to think about what goes into making a product good. And it really is all of these component parts. So setting the stage for healthier materials. The importance of timing. My colleague, Amy Johns, who was the sustainability director at Williams College for 8 years, used this slide in a presentation we did last fall. And so I can't attribute it, the image, but she did say that, this graphic is widely available and is shared by many because it points out the obvious, which is you have to think about these things at the beginning. What are your goals? What are your objectives? And if you don't define them well enough and think about them early enough, then the impact on your construction timeline and cost goes up significantly. So the importance of clear goals is something that we're going to talk about because if you are a practitioner in the healthier materials world and don't start to consider clear objectives for reaching healthier materials and what that means, then it will be more expensive. As an owner, clear intent articulated in RFP is really important, right? Because if you're going to build a building and you want to reach certain sustainability goals, you have to articulate those goals in the RFP. And if they're specific to things like material health, then you have to give that information to some degree in the RFP. Otherwise, you're not going to attract the right partners for your project because that's what you're doing. This is a marriage made to build a building. And if you're not transparent at the beginning through your RFP, then you might miss out on making the best match. So as I have been sort of alluding to, typically what happens is we refer to healthier materials goals. Well, what does that mean? Do we want all of our interior products to be red list free? Do we want some percentage of our interior products to be red list free? Do we want to achieve a certification that requires so many health product declarations or environmental product declarations? We really need to kind of spell that out. And that is a challenge. And that is something that as a practice, we do a lot is just, even if somebody's not inspired to get full certification, we help them identify and articulate healthier materials goals. And what we know too is that the design and construction teams are going to have to work on this during that early process to really hammer them out so that they have clear marching orders for both design and construction to achieve the goals. Specifications are critical. This is from my friend Lisa Goodwin-Robbins at Kalen Associates. She's worked on she's working on her 8th Living Building Challenge building, so has probably worked on more LBC buildings than any other architect in the country. But her role specifically is to create contract documents, the narrative to translate those ideas into action and to communicate clearly to practitioners, especially contractors and their subs, about what they need to do. So the Part 1 general requirements of the spec is really important for doing this, as well as the specific information pertaining to products. And we always say that even for our publicly bid projects where they have to list 3 and we might not be able to get to 3 good ones by the time of bid, it's really important to name that good one as the basis of design by product name and by manufacturer. Sometimes we have performance requirements in place of those names because we can't get to the names, and that's okay, but that's not ideal. The importance of process. So again, when we have really ambitious sustainability goals, whether it's net zero water, net zero energy, or healthier materials, we approach projects differently, okay? It's a little bit less linear because, as I suggest in this diagram down here, during the selection, identification, and selection of materials, there's a lot of back and forth that happens. And it's super important too when we have high-performing sustainability products in mind for our new projects, that we bring as many of the people that are going to be involved in constructing that building together as early as possible. So having the construction manager on board for really big projects, or having specialty consultants who might be providing some element of the design on board is going to be super critical early on. Another thing we've added is a pre-submittal process to our high-performing buildings that also want materials to be better, because we need a little bit more time to make sure the contractors have actually identified healthier products before they get into the final submittal phase. So it's a different mindset. It's integrated thinking. Are there things that can be eliminated so that we don't have to think about them at all? Can we use mechanical fasteners instead of adhesives? That's a really great example, and it helps with deconstruction. Communication is paramount, and goals are paramount. So what can the buildings teach us? So the research that we've done over the years has resulted in a materials library that is called Red to Green. And Red to Green essentially is a collection of all of the information we've gathered from over 3,000 manufacturers on over 10,000 products to date. It's not just our research. We have other project teams that license to use the platform, and they add new materials and new research as well. What I want to give you in this snapshot is that in the projects we've worked on, and in particular, the project that Carl mentioned, the lab building in Alston, 18% of the materials, so what we're seeing here, is the gray represents no transparency, no information. We don't like that. at least if we know there's red list, which is what the red represents, that's because typically the manufacturer has been transparent and said, yes, we have PVC, or we have neoprene, or we have PTFE in our valves as the seat material, but they're being transparent. And then the light green is those products that are red list free, but they're red list compliant. So they use that exception that recognizes a market reality. And then the green products are the ones that are truly red list free, which is super cool. I should say that within the light green are products that might be, the manufacturer might claim that they're red list free, but they don't give us full transparency. So about 18% of the products on the over 5,000 individual product types that we reviewed, 5,000 products that we reviewed for the lab building in Harvard, 18% of those have red list materials, okay? They don't comply. But 34% are red list free, okay? So that's great. 34% are red list compliant, and then the remainder are red list free. So the bulk of the products on that project are good products. They're certainly better than the market average. Another thing I want to highlight about this building, and I'm sorry to say I can't share photographs because it's confidential, but there are thousands of light fixtures in this building. I think there's something like over almost 6,000 different fixtures in this building. And of that, the majority of the fixtures are free of PVC-free wire. So because the project is large enough, over 550,000 square feet, and thousands of products in some cases being ordered, the primary lighting manufacturers were willing to work with the supply chain and find PVC-free wire, which is super cool. Another huge win on this project has been FSC wood. For their furniture package alone, which represented many millions of dollars, the RFP mandated FSC wood, which meant that some major furniture manufacturers, just to participate in the RFP, had to go out and get their FSC certificate to participate. And that's great, because what that means is that the next project that comes along might benefit from those entities changing out their wire or changing out their wood without having to do anything more than just ask for that same product. So those are two that I just wanted to highlight. A third element of the lab project that's notable is that because it was a new segment of the market that we were working in, the owner worked with ILFI to sort of, tease out the fact that there were so many novel systems in this lab building. Many of them were FFE, so they fall out of LBC scope because they were, the owner already had them, or the owner was purchasing them. But then there were many others, like operating tables and operating table lights and sophisticated equipment and that was used, as well as sort of all the systems that go in to make a lab. And they came up with a specialty equipment exception for us, which has a much lower threshold. Instead of asking for 100% transparency and red list free or compliant via an exception, it was a much lower sort of level of information disclosure. And that's important because we can't ask for everybody to get to, the end game in one step. And so by moving the market and asking the questions with these really special and niche-y equipment manufacturers, there's now a lab labeling program called My Green Labs. So that's just some of the things I wanted to highlight. here's a Candida building at Georgia Tech. And the image isn't great, I'm sorry, but it's actually from the Chronicle of Higher Education. And what I wanted to point out by using their image is that these buildings are getting a lot of press, okay? Because this is a time when we're all looking for solutions, right? We know there are a lot of problems out there and they seem insurmountable. And so we're looking for inspiration. And it's a great piece, again, in the Chronicle of Higher Education that highlights the 37,000 square foot building in Atlanta that Georgia Tech has just finished last fall. It's been in operation for a few months. And there are many special things to say about this, but let me give you a little bit more data. So 37,000 square feet, about 27,000 are conditioned spaces. They're going for the whole living designation, so they will produce more energy, and they have already produced more energy than they use. They're collecting rainwater from the solar panels that act as a solar shading device as well. Let's see, what else? I wanted to say that the cost per square foot of the interior sort of conditioned spaces is around $507 per square foot. The building manager, however, wanted me to point out that by virtue of producing way more energy that they need and also producing energy for surrounding buildings when they're producing more than they need, so they're giving back to other buildings on their campus, they've basically they've got their embedded energy, their energy paid for the next 25 years. So that is not factored into that per square footage cost of $507. And he made that point, and I think that's an important point that needs to be shared. So here's another cool detail. What looks like a manhole cover in the middle of the floor in the atrium is a manhole cover in the middle of the floor in the atrium, because this building has a 50,000 gallon cistern in its basement. Okay, and basically they wanted to draw attention to the fact that this building is it will be soon its own public water supply. They collect the water from the roof, they collect the water from the site. They have a sophisticated treatment system to treat the water that they will use. And they are obviously saving the public water supply system and sewer system a tremendous amount by virtue of doing this all on site. So it's a really, really cool element that should be noted. Another thing I want to talk about quickly using this image is the fact that they tapped into a new process called carbon cure to create all of the concrete on this building. So carbon cure is a technology that injects carbon dioxide into the concrete mix. And by virtue of doing that, it's kind of like using all the wood on the project. You have embedded carbon in your building, which is a great thing. It's like a carbon sink. And that's different from the embodied energy, which, again, can be really high if you use things like, lime, virgin lime, and in this process to convert lime into concrete is a really energy intensive process. And so by using this novel technology, they've really made a big impact on their carbon budget. These pipes that are all in this system would have been PVC, but now they're high density polyethylene. So if we think about things like pipes and electrical wire, and if we can use alternate materials in that situation, that's a huge impact. Another big impact was Kawanir, which is a big manufacturer of curtain walls, is based in Georgia, and they were able to get a ton of Declare labels through their advocacy to near to get those labels and also address chemicals of concern. So those were considered kind of two big wins in the materials marketplace. Here we have these panels. There are over 900 of these panels around the building. And the cool thing about them is that while they use new 2x6 wood and all of the other pieces of wood that are in the panels that aren't structural are all salvaged. And that salvaged wood actually came from Atlanta's film industry. The impact of using salvaged is really, really, it should be noted more often, because the amount of good material that ends up getting landfilled, especially from construction demolition of buildings, is significant. Okay, and if we can figure out how to harness those materials that already used energy and water to be made the first time, and we can remake them again for new purposes in new spaces, that's significant. The building operator wanted me to point out too that they developed a local workforce. It was a job works program to help people get job skills and get them back into productive careers. And 8 people constructed the 900 panels and now have some pretty cool skills to go out and do it again. Also, the glulam beams are FSC certified. The architect did an analysis that showed the difference between using the FSC wood versus non-FSC glulam beams basically is the equivalent of about 500,000 trees being planted. So it's really impactful. Using FSC protects the forest from, you know, just being abused and agricultural practices that aren't sustainable. And having wood in the building is great for your embodied carbon, but it really needs to be FSC wood. Again, all of this is salvaged floor. It's the primary central sort of gathering place and getting to the various areas of the building. The one thing I wanted to point out here is that this ramp that allows all of this space to be accessible is front and center. And again, when we talked about way back, you know, sort of the mission of LBC and promoting equity and justice, you know, having these design decisions that think about you know, how to create access for everyone. It's a great thing to see it come to fruition. So the attraction here is the toilets, okay? These are the composting toilets, and they are the most popular thing on any Living Building Challenge tour. It's hilarious and it's wonderful, and it's all about, you know, these buildings are living laboratories. So if you're lucky enough to be near one, go visit it. And please be inspired to think about ways that, even if it's not a living building, what are you doing in your building that's special and novel and worthy of a tour? I mean, that should be one of the benchmarks for sort of how we do our work in the future. Another thing I want to point out is, it's not a detail you can see very well, but the black tiles in this wall in the restroom and in many other spaces are, again, another salvage material from a rooftop of an old building at Georgia Tech, a stone roof that was being deconstructed, and they took those slates and cut them and created, you know, another way to integrate salvage material. They did that not just with the tiles here and the wood, but they also did it with a lot of the brickwork that is in this building. And here are the composting bins, and here's the cistern. And again, all of this open space down here is less about sort of operations and maintenance than it is that there's going to be some tours going on throughout this building's lifespan, so that people can learn about these systems. Here's a project that that used red to green. They used our materials laboratory. This one's out in Portland, Oregon, and it basically was a tenant improvement, largely a tenant improvement for the architect looking for a new office, and it was an existing space, an old stamping factory, and so some things to note here. Basically they had I think 30 declare labeled products that they used. They used due diligence for about 15% of their products, meaning that those were products that had red list in them. They basically were looking to use as much and reuse as much of the structural elements as possible, which are visible in this image. Like so many living buildings, they have concrete floors because hydronic heating and cooling is so efficient and can be tied into the novel water and energy systems. They were also really excited about the desks because instead of going out to a systems furniture manufacturer and importing something from a couple thousand miles away and maybe not getting exactly what they wanted, they took a lot of time to think about how they could create a workstation that would meet the objectives of the material petal. So it would be red list free, it would be FSC wood, it would be locally sourced, which Oregon, of course, has the benefit of having a good chunk of our wood industry located in the state. And they could really reduce, make sure they were controlling waste because, they only ordered what they needed in terms of the materials that go into the systems, et cetera. So that was a win. I will also point out they wanted me to share this photo because they really love their kitchen. But point out that so many of our buildings, living buildings, have these open plenum areas that show all of the systems and ductwork and everything, lights and wires, etc. That's great because it's part of being intimately connected to your building and understanding what's there and how it may be impacting you and how you as an occupant, when you change the command for more heat or more cool, how you might be affecting that system. It also is important to note that it eliminates materials, right? We don't have that ceiling system with all of its framing and hanging and wiring there. So my last project that I wanted to share is Nuthatch Hollow. It's up in Binghamton, New York. It's very close to the Pennsylvania border. It's not yet in construction. It will be publicly bid, and it's only 3,000 square feet. So that makes it hard to sort of move the market, and a little bit scary when you're going out to public bid because you're not going to have the opportunities of that large lab building to leverage your purchasing power to have manufacturers change things. It's on an existing a developed site. There's a small ranch house here that will be demolished except for its foundation. Most of that foundation will be reused because it's concrete. And again, we're trying to reduce the impacts of building materials and reuse as much as we can. So they're reusing that foundation. It really takes advantage of the 30-acre site. They're lucky they have a well already on the site and the ability to increase the capacity of that well to serve the occupants. And they're going to go with photovoltaics. They looked at geothermal, but for the cost, the photovoltaics made the most sense. And like so many other projects, Kern and Hitchcock, notably, they use a lot of natural materials, the wood and the stone being representative of species that are on the site and stone it's locally procured. This volume here on the right represents the existing building foundation. It's a little bit hard to see, but these are open spaces. This area is lab sort of a much simpler lab, not a sophisticated research lab, a field lab, if you will. This multi-purpose room is being designed so that it can meet many different user needs. And that's important. Again, when we have flexibility of spaces, and this is glass, these walls are glass instead of gypsum boards, so they can be, reconfigured sometime in the future if the space needs change. Again, a large mechanical room that will be the subject of many tours. And so I think that's what I wanted to say. The Nuthatch process highlights some important high-level things. Certification holds you accountable for achieving your goals, okay? It's great to be inspired. It's great to have sort of, campus-wide initiatives or practice, maybe your future architecture firm or building contractor will have certain goals, but how are you going to get there? And certification helps you do that. Design team education, this should say really all team education, okay? Because basically everybody has to know what the goals are, why you're trying to achieve them, and how they have a role in achieving those goals. The stories that Jonathan Wright of Wright Builders tell about the Kernan Hitchcock Center are really wonderful, because he talks about how the trades got so invested in their work and in that project because they realized that it was so visible, would be so visible to future building users, and would be so noted both through celebration of the certification and by people visiting and taking tours. Focusing on high cost, high volume, must-have product types. How do we get those right? Those are the things that we spend time on when we talk about materials early on. Intentionally specifying, I mentioned as well, name a product, name a manufacturer. We have pre-submittals, that process I mentioned where we might need a little bit more time to know that the contractor who's bidding on work and who has won the work understands what they're supposed to do. And then regular project check-ins with all stakeholders. Are we all doing okay? Regular meetings to kind of talk about what's up and coming in submittals, and also, if there are any more problems that need to be solved. So this is my quote, okay? I didn't attribute it, because this is what I want you to walk away with, is that each material that I choose, it represents so much more than just a building block in that building. And if you take away nothing more, I want you to think about that whatever your future role is, it's more than just getting the job done. You have the potential to make an impact across those hosts of issues, climate change, safer product chemistry, better cognitive functioning. All of those things are things that you can work towards. And I'll leave it here. And I know we have questions now, but here are just some of the resources that I tap into on a regular basis, that you can tap into as much as you wish and learn more about some of the subjects that I covered today. So thank you.
Thank you, Lisa.
Yeah, that was terrific, Lisa.
I'm gonna get a little drink now, but I'm ready to field the questions.
Yeah, those are well-deserved accolades that you would have been receiving in person.
Yeah.
A few applause hands are going up, digital applause hands. But I think you're not this slide, a good appropriate slide, but the two previous slides are the ones that were really inspirational.
Great.
So I would only lead off with one question. If you were advising a person who was inspired by this lecture, how do they get to be you?
Oh, goodness. That's not a fair question, Carl. All right. Let me say something that surprisingly I didn't state during this talk that I typically do when I talk about healthier materials. And that is, most of us are not chemists, okay? if you had told me in high school and college when I was suffering through chemistry, that I would be using chemistry every day in my life at some point in my life, I would have laughed. It would not have been conceivable to me how I would have used that chemistry. Having said that, if you can take an applied chemistry course, that's a cool thing. That's great. That would be a great thing to have in your back pocket. Okay, so let's say you're not taking chemistry and you want to get into this as soon as you can. I'd say first and foremost, visit some of these websites. Okay, just again, becoming comfortable with the language around everything from product chemistry. What does that mean? Those are the constituent elements in a product. Embodied carbon. Again, I think that's going to be bigger. Maybe bigger is not the right phrase, but I think that's going to be really a key factor in building design and construction moving forward. It has to be. We only have 10 years to change course on carbon emissions and climate change. So becoming familiar sort of with the labels is important. If you want to learn more about products, again, Kath and I did not have declare labels to look at for Williams College, and they started to really come to the fore in 2012 when Kern and Hitchcock were starting, and they had like a dozen then. Now there are hundreds. So you can learn so much about products by virtue of just looking at those labels, and you'll start to see some common ingredients. And then I guess the last thing I'd say is please watch the 6 classes video. I wish those videos existed when I started out, because they tell you where chemicals of concern are, both in building materials as well as in consumer products. Like, there's PFAS in my dental floss. Now there isn't because I changed my dental floss, but it's really eye-opening to sort of discover. And I think if somebody took 8 hours, took a day to look at all these different resources, watch the videos, they would have a 3-year leg up on where I was. Because really it was sort of traumatizing to be told to figure out if a light fixture was compliant. I didn't even know what went in a light fixture. So
a good answer.
Lisa, are manufacturers proactively cataloging their products for LBC compatibility, or do most wait until there's an LBC project that needs the data?
Okay, so let's start by saying that all manufacturers of products have to catalog their products already for environmental health and safety, for those very basic safety data sheets and material safety data sheets that tend to be circulating in the market. Okay, they're just not being transparent about it, and for some of them, where they put together a lot of different component parts to make the final thing, they have no awareness of where those component parts are coming from and what the chemistry is of them. So since I started working on my first LBC project, when it started like a public service announcement research project, today, typically when we call manufacturers, I would say more than 60% know what we're asking them for. Still, probably fewer than 50% have it readily available, okay? When I mentioned the explosion of labels, thousands of health product declarations and hundreds of declare labels and again, thousands of EPDs, those tend to be companies like that have repeat products that are being, or different products that are being labeled. So for instance, Mohawk, I think, has something like 15 declare labels. USG has another 12 declare labels. for different products. So what's helpful about that is, first of all, you know which manufacturers are really good, and you should start with those. But for manufacturers who aren't doing it yet, what's helpful is you can pull those labels and take them and show, email the manufacturer the link to a product that's like theirs on Declare, or email them a link for a health product declaration that exists for a product like theirs. And boy, does that get a reaction.
Oh, I'm sure.
Yeah.
Yeah. Okay. Can you revisit the slide on labels? I guess we have to, there are two questions, two requests to revisit a slide. So I guess.
So which
before you.
So is it about talking about what the different labels do, Kath? Or is it a Declare label?
No, you had a slide with
all the little tiny
five or six different labels. The Declare label was one of them. Cradle to Cradle was one.
Right. Okay. So now I need to.
Right. Now you need to go back to your slide.
Yeah. Okay. Hold on. I got it. I can do it.
Okay.
Okay.
There you go.
Oh, is it there?
That's it. Product certification.
Okay.
Yep.
So, and let me go to the view so you can see it better. All right. Not being quite sure what the question is. So Declare and health product declarations, HPDs, offer they offer many things, but they get to transparency because they give you all the ingredients. Usually there's a tolerance for 1% proprietary. So there's 1% of product chemistry that a Declare label or an HPD that the manufacturer doesn't have to disclose. A Declare label, because it's based on LBC's red list, is giving you a determination, okay? It's saying this product's red list free. There's no chemicals of concern, or it's LBC compliant, which means maybe it's a light fixture and they have PVC-free wire, they have, all their components are compliant, except they rely on an exception, and this is an example of an exception, called small electrical components, which is essentially that LBC allows for products that have an EU mark that's called the Restriction of Hazardous Substances. If they have that EU mark, they don't have to disclose the ingredients of the driver and the PCB board and other small electronics within. So that's an example of using an exception. So the light fixture is all great, but they have these RoHS compliant parts. And then the last one is declared. Again, it's fully transparent, but in bright, bold red letters on that label, you'll see what the red list is, which is why I said earlier, it's a great place to go and learn about red list and where they are in different types of products, because it'll tell you. A health product declaration does something slightly different, because in the disclosure of individual chemicals by CAS number, it also it offers sort of the role of that chemical. So for instance, if you wanted to avoid flame retardants in your furniture or in your window shades or your carpet, what you would look for is flame retardant, okay? Because what an HPD does is it tells ingredients by virtue of kind of the role that chemical plays, okay? So it might be a pigment, that's a role. It might be a flame retardant, that's another role. Or it might be a water repellent, and then you think, is this Teflon-based water repellent? An environmental product declaration, again, UL Spot is a big repository for those. Those talk about greenhouse gas emissions, impacts to water, but those are really the ones where you're going to get the carbon information. And I think the next slide I showed, where was it? Sorry. Okay, this slide, which is relevant to sort of embodied carbon data. If you're going to go into the building sector and you're going to do modeling, maybe you're going to be involved in building energy modeling, or even if you're a contractor that's selecting materials, these tools, Tally, that's part of as part of Revit, and EC3, which is a public forum, it's free, you can go there today and look at it, are the repositories for EPD information. So for future information, sort of trying to make a decision about this concrete mix versus this concrete mix, this insulation type versus this insulation type. All of those are really important, I think. And then cradle to cradle, again, it's not transparent, but it has values based on material health, material reutilization, that's, recycled content, energy, water. So that, I'm going to stop there.
Yeah, no, that's great. Thank you. And can you go back to the last quote, the slide with the last quote?
I can.
For a moment.
I can do that by not scrolling through.
And while you're doing that, Carl, how are we doing for time? Oh, you're muted. We can't hear you, Carl.
It's 5:20, so I think we probably lost some people.
No, not many. So what I'm going to do, though, is people who have other obligations are certainly excused. If you'd like to stay for a little bit, that'd be fine. Lisa will answer a few more questions. We'll probably wrap it up in 10 minutes or so at the latest. So no problem for those of you who like to or need to leave. Bye-bye to those.
Okay, very good. Okay, Lisa, this comes from someone who said, I've worked with integrated eco strategies to get my company's HRVs and ERVs, Ventacity systems, on materiallybetter.com or within Red to Green. Is there a way to find these products on the website?
Oh, okay. So first of all, thank you for working with us to get us your material and your information on your products. That's awesome. Right now, Red to Green is, we offer subscriptions. And we do that primarily because we've poured a tremendous amount of resources, both money and people time, into developing this repository of information. And we're still trying to figure out, by virtue of, having worked with a number of project teams over the last 2 years that have been testing the platform, as well as, paid subscribers to the platform, how best to make sure that this information is available to all. But unlike Mindful Materials, which is available to manufacturers to post information for free, and Declare, where obviously you can get on Declare, but you have to buy a label. We don't offer Red to Green as a repository for a manufacturer who's on there to say to a design team or a contractor, hey, if you want my information, you should just go to Red to Green. What I do always is, when I'm finished pulling together the data for Red to Green, again, it's based on what the manufacturer provides to me or your supply chain. I give that back to them. So I've given plenty of manufacturers files of information from their suppliers, and typically I'm keeping the manufacturer in the loop with the suppliers at all times, because you're offering me some leverage to have those conversations. So I'm not sure I answered the question, but please feel free to get in touch with me after the talk, and I can explain it more clearly, thoroughly. Oh, Kath, you're muted.
Yeah, thank you. My child is practicing Kung Fu downstairs, so I'm muting myself while I'm listening. So what is the typical cost of certification as a percentage of overall building costs if one were to comply informally with the LBC goals?
Wait. Okay, so repeat that. If one were to comply...
I guess even if you were going to comply
it's
formally.
It's a two-part question there. What's the cost of certification? That will depend on your project type, size, the number of petals, because like Kern and Hitchcock and the Candida building are going for full living certification.
Right.
So, those projects just on paying to get certified, it's like LEED. It's going to be, a couple of $1,000s or $10,000, depending on your project type and all of the other things that you are doing to register. Let's focus on materials. For materials work, generally we say it's about 2% of the materials budget. It can be less, okay? It can be as little as 1% of the materials cost, or it can be a little bit more, but that's the number that we've come up with based on all of the different project types and their different programs that they've been creating, right? Because a lab building with all of its sophisticated equipment and much more equipment is going to be very different than that tenant project, the Malem, Portland, Oregon project. They looked at 350 products versus the 5,000 that we looked at for the lab building, right? So obviously there's a wide range of costs, but generally we say it's between 1.5% and 2% of your materials cost that will be attributed to getting LBC compliant materials. That's not your soft costs for the research. And soft costs have really come down significantly, because if you have a design team that's willing to specify using existing declared products, health product declared products, declared products, you are already a good chunk of the way there. And one more point on that. People always are going to specify concrete. They're always going to specify some miscellaneous metals. They're always going to get furniture, and all of those things offer. Those are materials that once you get your palette, you reuse again and again and again. So it's kind of that first cost, first project value, but then beyond that, you're just going to be building on that repository of those sort of standard things.
And for LBC certification, broadening our scope out to, the cost of the full certification beyond just materials, what's the range of the percentage of overall project cost that certification represents? I mean, I know it depends on the kind of building.
Yeah, I don't think I'm going to want to put that number out there, because I'm going to get it. I'm going to get it wrong. It's really, I tried to illuminate that, again, for the Georgia Tech project, and I showed some pictures. They have a fairly simple material palette. They have a lot of wood. They have concrete. They have one area that's carpeted. They obviously have all the light fixtures and the composting toilets. That was $507. For all that finished space. It was something like $350 for the whole project. So the cost per square foot, if you consider all of the project program spaces, not just the conditioned spaces, if you consider all of the space, it's like $350. So again, and again, making that point of the energy costs, which aren't factored into that. So, some of that square footage cost is attributed to materials that are novel for your energy and your water systems. And yet you're not, once you get those systems up and running and everything's working well, you're banking, you're not spending money on those utilities that you would otherwise be spending, which for public buildings, buildings with higher occupancy, that's significant.
Right.
So perhaps we should close it out now.
Okay.
So that's a good note to end on, that it seems like a reasonable economic venture to execute.
Yeah, and certainly to start, what I want people to know is, if they have to purchase something tomorrow, if they're going to get a chair for their office, or they're going to go get, something for their own selves, try this work on their own terms. It's like, if you're buying from IKEA, guess what? You're going to find some great sustainability information that speaks to healthier materials on their website. But if you're going to the store down the street and you say, does this have flame retardants in it? That's going to be a different discussion, but totally worthwhile in having. And you'll learn a lot, and so too will the person who you ask that question of.
All right, well, we can't thank you enough.
Sure thing.
If we were in 170, we'd be giving you the coveted BCT water bottle.
Oh, hey,
You'll have to wait.
I've got one, so you can save the embodied emissions from yours, and I'll just have mine that is working. Thank you.
Right. So we can't thank you enough.
All right, well, bye everybody, and please do, get in touch if you have any questions.